This discussion was actually, the SIOS began 2 years earlier. I was telephoned from the ministry in Oslo, and they said you have to get involved with SFRI. And I didn't understand what was going on, and I ignored it. But then I was told with uncertain terms that you have to go for SFRI. So in 2007, we indeed discussed this. The discussion was vague. SFRI was emphasized, and I embarked on an unknown voyage into the future. And we'll acquaint ourselves with that. What is SFRI? This was, it was a European Strategy Forum on Research Infrastructures, and it has some boring text about what it does and what it should be. There was quite a lot of enthusiasm, but also misunderstanding of what was it all about. I think in Norway, one thought that SFRI, the European Union, would be paying for it. But in fact, SFRI is, of course, instrument where the nations are paying for their parts. And this seemed to be unknown to some of the people involved. Very soon, the question that has plagued us all along is, what is it in it for me? And me can be very many things. It can be the individual scientists like yourselves. It can be your group. It can be your institution. Then there are other intriguing optimizations by the ministries, nations, European Union, and also globally. There are many that are not in the room today, that are part of SIOS from Asia and also within Europe. We have some online, but not everyone. And what are the incentives? Idealism, career, funding. For some of the institutions, it's avoiding costs rather than getting funding. And there are power games and maybe obedience. I was ordered to build a SIOS. One complication all along has been the balance between these tension lines up on top and the Svalbard Treaty. In the Article 3 of the Svalbard Treaty, the nationals of high contracting parties have certain rights. So we're talking about subjects of the co-signing nations. It is not the countries that have rights, it is the nationals. And in the end, that made the SFRI instrument impossible because it suggested that nations had power here in Svalbard. We had high thoughts when we started out. Environmental and climate-related challenges require an Earth system approach, and no single institution or nation can fulfill them alone. And I still believe that there is unreleased potential in Svalbard that we are here together to approach. I pose it that observational strategies need to be designed around multidisciplinary considerations. We have a tradition of doing it in meteorology and oceanography, but we need strategies that combine disciplines. And I also pose it that observation systems have not developed in the same systematic approach as the modeling has. And if we go back to 2007, we are talking about assessment report 4, AR4 in IPCC. And this cartoon shows you the development of climate models. When I was a junior scientist, up on top, we had climate models that were very simple. We had rain from the clear sky, not because we didn't know about clouds, but because the computers could not handle clouds. And of course, there has been a lot of research done and developing when we see that we need new processes included. And there has been a systematic development also of the resolution of the models. The region up on top, you might not recognize, but as computers and models developed, there was a systematic approach to how many grid points you need in order to resolve a cold front or whatever. When we do measurements, we are in fact still haphazard. We are in Longyearbyen, we are in Ny-Ålesund, because there was a coal mine in Longyearbyen and Ny-Ålesund. It isn't necessarily the best place to measure this, that, or the other. At that time, there were also papers produced. This comes from an NSF effort in order to discuss what must be resolved in a good Arctic model. And of course, you can need data to make a model. And if you, but the reverse discussion about what kind of measurements do we need in order to be able to calibrate and validate a model of this type is not so much discussed. There was also a paper by Lindemeyer and Likens, which suggested adaptive monitoring, and they had a nice scheme with models and predictions and all the way to improved models. And conceptually, this paper is fascinating, but they offered no real advice about what goes into the arrows. How can we make this loop work? And it certainly inspired us in many ways. They talked about how to adjust design based on new technology, and they discussed all of this, but not the process that the arrows involve. And this science wheel is our response to how to do it, how to actually make observation systems adapt as we go along. And clearly the SES reports and their feedback into the process of SIOS is a little contribution in how to systematically build observation systems. And I hope you can see that. There is a role throughout. Now, many of us underestimated the challenges with organizing a decentralized infrastructure and the elusive mutual benefits up on top, actually addressing big questions. What is it in it for us? What is it in it for science is certainly something we still are working on. The mission of SIOS to develop an efficient observing system, to share technology, close knowledge gaps, decrease environmental footprint of science. So, what should we be doing? And what might we want to do? Well, we want to design observation systems. How many ants do you see? Maybe you can count them. But in reality, the ants are not sitting around. And now it is much harder to get a good count. However, we might find a PhD student, and with some observations and some statistical model, we might get a population estimate. And it doesn't really matter where this PhD student stands, as long as the system is thus equally dispersed in space and time. Reality, Svalbard is much more complex than that. Sometimes there are various reasons why it is not homogeneous. And the point I want to make here is that we must understand the system in order to be able to make good observations. Our student might see no ants or a lot of ants. And the question is the system organized or is it chaotic? We must understand the system and explore it bit by bit. Monitoring long-term measurements that SIOS is very much about is also, so this is totally theoretical figures, but if you have 3 scientists and they measure some entity and it goes up, does that give us knowledge about what will happen in the future? Society asks of us to provide estimates of the future, predictions. But in these 3 particular cases, mathematical game, the development was very different. The point being, monitoring itself does not reveal anything about what will happen later. We need to understand the processes. Monitoring, we must, but without science in parallel, SIOS has no future. We must be doing it. Technology is also important in order to decrease our environmental footprint. Some of our polar bear scientists might not like this slide, but it certainly, one inspiration I have had regarding how should we do it is if you ask the question, is there life on Mars? You don't send students out to capture butterflies. You think high tech. And we should be looking at the polar regions as Mars. It's convenient to fly a helicopter here, there, and everywhere, but maybe we can be more clever. Is there life on Mars? Well, you go high tech, you have various instruments, but you're faced with many questions. This up on top here is minerals from Mars, where they found some interesting formations that maybe look alike a worm-like creature, possible fossils. Here are other worm-like, this is a sausage maker in Italy. What are the criterions that we need knowledge in order to do that? This was also happening at the end of 2007-8, the AMAZE project. They were in Svalbard looking at high tech. We should go high tech. The future is in higher education and high technology. This was something that a minister in India said when I visited there in 2011. Everyone sees a future in it, but we have to explore where we have a role. This is a road in Arizona. Now, roads in Arizona go straight forward. This is high technology from the United States of America. Excellent when you want to drive straight forward. This is Rome. We're a different place. This is high technology from Italy. Excellent in Rome, but not very useful in Arizona. This is Holmén. We want to count polar bears. We as a community, a SIOS community, have an important role. And the point I want to make with Arizona and Rome and Holmén is, and India and the world, we are strong by where we are and our knowledge about Svalbard, and thus who we are. And this is something that this community, sitting in this room, we are the strongest knowledge makers, knowledge carriers of Svalbard. And there is something there we have to help each other do. We have strong ambitions. We will be the leading comprehensive long-term observation system in the Arctic to serve Earth system science and society. We produce SES reports. You produce SES reports. And these are totally fundamental in the development of the observing system that I hope that we want to go ahead with. And recently, and polar research is somewhat confused. It's either published on the 31st of December or on the 2nd of January. But anyway, this is one example of how the Svalbard science community has actually developed one small aspect of observation systems. It's a great success. And they have some recommendations for focal sites. But as I already mentioned, are we systematic? Yes, we're getting there, but we still have a ways to go. So, SIOS, a vision, maybe a dream, some misunderstandings, but there are some great opportunities that we should be grasping together. We've come a long way. We're working with global issues. We're working with environmental research. We're working with long-term observations, cooperation, coordination, innovation, maybe cost efficiency, certainly scientific excellence. But there are also some other sort of subtle things. SIOS is a vehicle. If we make international commitments, they are likely less prone to be cut as other funds. So we can depend on each other. And then maybe some idealism, certainly something that has inspired me through the years, that scientific cooperation in the Arctic can be a showcase to a troubled world about the benefits of peaceful interaction. A new idea comes. This is an Einstein thought. A new idea comes suddenly, but in a rather intuitive way. But intuition is nothing else than the outcome of earlier intellectual experiences. We need each other. We need each other's intellectual experiences. Young, old, together, we can come up with great new ideas. And we can come up with great new CES reports and develop the observation system and be a strong force in IPY 32, certainly ICARP, which we will hear about in a few moments. And with that, I want to end with some philosophy. This is the time spiral of the planets. We began 4.5 billion years ago, and nothing much happened until about 540 million years ago, the Cambrian period. And we have all the deposition of coal, dinosaurs up on top, and walking towards the present and the last 2 million years when humanoids have been around. I use this slide on many occasions. One statement I can make, a little bit tongue-in-cheek, is it was not sustainable to be a dinosaur. The main point is that there is nothing in this figure that shows any status quo. We are constantly changing as we go through time. And the SIOS voyage that we embarked on many years ago will never be finished. We are here together to look and build into the future. It will not be like it was, but we should be strong together. And with that, I want to show you some friends here in Svalbard with less ice to rest on than before. Thank you all.